Welcome, everybody. Just a heads up, I do speak kind of quickly, and this typically is a 45-minute talk that I've condensed down to 25 minutes, so I am going to speak fast. We're going to cover a lot of ground. I love to code. I'm sure we all do. I did not start coding. I actually started in IT. I used to manage systems, but the coding bug bit me way back in the MySpace days when I learned how to customize my profile. Any other MySpace OG developers? Oh, wow, a lot of people here. That's great. So I got my start as a software developer working in IT when my boss came to me and said, hey, we are paying this consulting company to make an API for us. We want to take it in-house. Would you like to do it? And I'm like, heck yes, I want to do it because I want to write code. So I build my first feature. I'm ready to ship it, and I call the consultant and I say, how do I get this thing live, right? Because I'm expecting, based on my experience, I'm going to be building things. I'm going to be FTPing things from server A to server B and restarting and basically doing that, right? He goes, no, all you got to do is just merge to main. And I'm like, my mind is completely blown at this possibility. And this is before the popularity of services like Vercel and Netlify. So what we are going to do today is we're going to break down how Netlify works. I've never worked for Netlify. I am not giving away any trade secrets. So this is all my inference. But that is me. My name is Brian Morrison. I'm a senior developer educator for a company called Clerk. Clerk's a user management platform. My job is basically to help people online learn how to use the product in the most optimal and efficient way, and just generally nerd out with people on the internet, which is actually a pretty cool gig. But as I said before that, I was a full stack developer. I was a systems engineer. I've been networking. I have an amazing wife and 3 beautiful children, all crazy psychotic boys, but I love them to death. And I'm also a gamer. And my game of choice is Destiny 2. For those of you who know me well, that's not a surprise. And that's going to be an important detail as we continue on. So as I said, we're going to look in the process of deploying to Netlify. Who is not deployed to Netlify or Vercel, by the way? Okay, good. We actually do have a couple people, so that's great. So step 1 of getting code onto something like Netlify is you write your code. This is kind of generally the experience. You write code, you commit your code, push it up to GitHub. Netlify comes along and works some kind of magic behind the scenes, and then all of a sudden, your site is live. So the question we're going to answer today is how this magic works. If I had to break it down into a single word, I would say DevOps. Automation is another great word that can swap in there. But let's take a look inside of Netlify's black box. These are the 5 phases that are shown in the Netlify dashboard when you go to deploy a website. This is pulled directly from the configuration of a website. If you go there, you'll see these things: initialize, build, deploy, cleanup, post-processing. Taking a deeper look into what each one of these things do, this is the initialization process. We're going to start by spinning up a build container. Back, like I said, in the old days, you used to have dedicated build servers that had all of your underlying dependencies pre-installed, so you can build things like Node, NPM, so on and so forth. Now we use containers because it's a small, ephemeral thing that we can spin up, do our work, tear it down, done with it, toss it away, right? Netlify also installs dependencies, so if you're in a Node.js project, npm installs run here. The next phase is build. We're going to build a site, npm run build. If you also have serverless functions, which Netlify does support, your serverless function binaries are going to be built here as well. Step 3 is deploy. We're going to take those artifacts, that's a fancy term for the deliverables of the build process, and we're going to put them onto publicly accessible servers because people need to access them in some way or some shape, way, form, etc. Your serverless binaries are going to go there. Files inside of their CDN is going to be replaced. For those of you who don't know what a CDN is, it is essentially a global network of access points around the entire world that can put code geographically close to people who need to use it. This means that if you have an application that is used by people in the US as well as Europe, if your code is closer to them, they can access it faster because Netlify still has not figured out how to solve the problem of physics, so that helps. And then finally, we update routing, so if you put new stuff into Netlify's network, it's accessible. Cleanup is actually a pretty cool phase here, I think, at least for what they do. They cache the artifacts for rollback, so if you add some code to a website that isn't quite working the way you expect it to, and you see it, and it kind of gives you that, oh, sugar moment of what's going on there, you can press the button and roll it back. We're also going to cache our build in dependencies here, so you don't have to pull down nearly as much the next time you go to run your builds. And then finally, post-processing is Netlify-specific stuff. This is a screenshot from an application that I worked on. I use Netlify forms inside of this application, so this is where all that stuff is kind of set up on their end. So now I'm going to give you some categories of tools for you to explore to build your own black box, right? Where the whole goal is to get away from using Netlify or Vercel or whatever to build something yourself and get excited just like I was way back in the day. So the first tool, this may not be in the same sense of the way we think about orchestration like Kubernetes, but I still call this orchestration as a category of tools, this is like your Puppet Master. This is what's going to pull all the strings, run all the commands, move the code from point A to point B, and do all the stuff behind the scenes to create your artifacts, right? We need a place to store stuff. Files, storage, and hosting is important. Content Delivery Network, CDN. I don't think I pulled out the full acronym, but that's what that is, and we talked about that for a brief moment earlier. Backend code execution. Most websites are not static websites. You need a way to interact with your backend with the database and somehow, so you need a way to execute code outside of the user's browser. We have routing. Again, when you're pushing new things out onto the public internet, whether it's AWS, Azure, any cloud provider, those rules need to get updated so this way people can access your new stuff. Authentication. I left this in here because Netlify, I'm not sure if they still do, they did at one point have an identity service. I'm a fan of using professional services for authentication. I work for one. Kind of feels self-serving to leave this in, but I wrote this talk before I ever worked for one of these, so I left it in. Plus, it's my talk, get off my lawn. And don't tell clerk I said this, but infrastructure as code is probably my favorite category of tool here. This also feels pretty magical even behind the scenes. It basically lets you define all your components of infrastructure inside of a glorified text file. The IAC tooling will look at that and find out what do I want, what exists right now, and it will try and make them match as best as possible. And that brings me to Guardian Forge. I told you my game of choice, Destiny 2, was going to be important. Guardian Forge is my application that I built for players of Destiny 2. It lets you take snapshots of your character data in-game, optimized for specific activities. I built this, the idea came to me because I like watching YouTube videos of how to properly optimize my characters for harder activities inside of the game. And I'm like, as soon as I finish that video, information's gone, right? A shareable link of all that stuff that somebody's character would be pretty cool. So that's what my service does. I am using a bunch of services behind the scene in order to deploy updates for Guardian Forge, and it's way more complex than it needs to be, but nonetheless, it's really good for doing this talk, so we're going to dive through them all. For orchestration, I'm using GitHub Actions. Whenever I push something up into my repository, GitHub Actions notices it and runs a bunch of scripts and workflows in order to make my application live. For IAC, I'm using AWS SAM. SAM stands for Serverless Application Model. It basically takes that giant text file, which in my case is YAML, and creates all of the necessary components inside of AWS for me to be able to host an environment for Guardian Forge. For file storage and hosting, I'm using AWS S3. In a nutshell, files and folders stored up inside of AWS. It gets a little deeper than that, but you can also make these files publicly accessible, so I use it to store all the artifacts for the publicly accessible web versions of Guardian Forge. Content Delivery Network is going to be CloudFront. It is AWS's flavor of a CDN. Routing. I included CloudFront in this as well, being highlighted, because CloudFront does actually do a little bit of routing for me. So Guardian Forge is actually 3 front-end applications. I have 3 apps, one for the main website, one for docs, one for the blog. And CloudFront can actually intelligently decide depending on the path that's coming in, which subfolder of my site bucket it's going to route that request to serve up the correct React application. Oh, backing up, hold on 1 second. Route 53 is AWS's domain registration service. The reason I'm using that is because I can programmatically hook into that to create subdomains. If anyone has worked with preview branches inside of Netlify, you'll know that you can actually create a separate branch, create a pull request back to main, and then see a preview of that environment without actually affecting your production. So I'm using Route 53 for that. And then API Gateway on the bottom there routes backend requests to my Lambda functions, which is all these serverless functions that do all sorts of different things depending on how the request comes into the backend. For completion, I included Bungie's actual OAuth. Bungie's the creator of Destiny. I'm just using Bungie's OAuth system because if you're going to use Guardian Forge, you need to be playing Destiny, and you need a Bungie account, so there's no need for me to use any other providers beyond that. So there are a couple of other services that we did not talk about in this diagram we're going to get to. The first one is DynamoDB. That is a NoSQL database that works inside of AWS. That is deployable from AWS SAM. If you're using something with Netlify, I don't think to this day they support an in-house database system, so you have to go outside of Netlify to do that. AWS has it included, and I can configure it with SAM. I also have SQS there. Back up just a moment. Getting a little click happy here, hold on 1 second. So SQS is a queuing service, and for those of you who are not familiar with queuing, it's a fairly simple concept, but can also get technically deep. You have one application on the left, right. You have 2 applications right on either side and a queue in the middle. Application A drops a message onto the queue. Application B picks that message up from the queue, does stuff with it. It enables asynchronous processing of data within the Guardians Forge backend, which I'm going to show you why that is important right now. So I've rearranged my diagram to show all of the things that happen when somebody creates a build. A build in Guardian Forge is kind of that core entity that creates the shareable links, right? And in a nutshell, it just said the user's computer is just going to send a JSON body payload back to my backend. Route 53 is going to help resolve it to the correct API gateway instance, and that JSON payload is then going to go to a Lambda function, which is going to do some stuff with it. There are 5 distinct steps that need to happen for the build creation process to be complete, but only the first 2 are required before I can respond to the user and say, here's your link, have a nice day, go do what you will with it, right? First thing is I'm going to take that JSON payload and I'm going to store it directly in an S3 bucket. Again, since S3 allows me to access files to the public internet, I don't need to consume database storage, which is more expensive than S3, so I have some cost savings that I'm able to implement with this approach. It's also going to be faster since I can just request that JSON file to render that data on the page. I don't have to actually do a lookup inside of the database. But then for some features, I actually do need a stub of that data stored inside of DynamoDB. That's the first 2 steps. That's all that needs to happen before I can give the user that link so they can start sharing it. On the back end, the next thing that's going to happen is that Lambda function is going to drop that JSON payload onto an SQS queue, which is then going to get picked up by another Lambda function to do some post-processing stuff asynchronously. First thing we're going to do is we're going to create a nice preview image. So this way when somebody shares a link on Twitter, by the way, it is still Twitter. I am dying on that hill, okay? That gets stored next to the build data inside of the S3 bucket. So this way, when it gets shared, that's the open graph image that's going to be pulled up to preview inside there. The next thing it's going to do is it's going to transform that data and ship it off to Algolia, which I use to power search on the website. That does not need to happen before that link is shareable, which is why I can handle it after the fact. Sure, somebody who's searching might take an extra couple seconds before they can see it in the index, but that's a hit I'm willing to take. And next, because I like the dopamine hit that people are actually using my stuff, I will send myself a little message to feel good about the things that I built in Discord. Okay, back to where we were before. This is our original diagram. So what happens if I create a branch called CYC demo and I create a pull request? GitHub Actions is going to take that, use AWS SAM, and spin up a completely fresh vanilla environment of Guardian Forge for me to test out that preview branch. And that is all powered by the IAC tooling that I've created. We've looked at this visually. Let's dive into a little bit of code now. Again, since this is a kind of a lightning version of the talk, the original talk actually has a live demo of me doing this stuff, but we're just going to dive into some of the files here. All of the code is open source. You can access it using that URL. You don't have to write it down now if you are interested in diving into it. I got a QR code for you to scan later that'll show you all of the resources and stuff we're talking about here today. So this is a YAML file. This is actually defines the workflow for GitHub Actions to deploy the front end of Guardian Forge. I wanted to start by keying in on line 3, the on section. These are actually the triggers that are going to start the process of deploying this. You will notice on line, 9 there, that I'm only monitoring changes to files inside of the front-end/public folder. I like to work inside of a monorepo. I like my front-end code and my back-end code staying in the same repository. And my back-end code's actually all written in Go. I don't use JavaScript on the back-end. So that means that if I need to go to Guardian Forge and say I typo something, I don't need to actually redeploy the whole damn thing. I can just deploy the front end using this workflow. Next step here is we're looking at environment variables that are set for all of the jobs for this GitHub Actions execution. So I'm setting my AWS keys here. This is more or less a programmatic username and password, so this way GitHub Actions has the ability to hook into my AWS account to deploy resources. And depending on the environment that I have set here, I can deploy to my production account versus a test account, whatever I want here. Now we're going to look at the start of this job definition, which is going to execute all of the sequential steps required to get Guardian Forge out into the public. The main thing that I want to call out here is on line 20, I have in runs on Ubuntu/latest. Everything that is going to happen inside of this workflow is going to be in an Ubuntu machine. But if anyone here has ever actually built anything for the Mac ecosystem, for Apple, iPhone, Mac, whatever, you need to build on a Mac. You can't do it on any other machine. So this is kind of the first main superpower you get by doing this, is you can specify the underlying operating system container that's going to build whatever you're trying to build. You're not limited to just shipping websites or using Linux or whatever Netlify uses behind the scenes. We're going to cruise through all the steps of this just to kind of try and one-for-one match this up with a little bit of what Netlify does. The first thing I'm doing here is I'm extracting the branch name for which the PR is created. And this is how I can create the specific environments inside of AWS for each individual pull request. Checkout essentially clones the repository inside of the build container. I told you I'm crazy and have 3 applications. I have a shared component library, so I'm able to use that and build that for the front end here. Transform configs. We didn't really see this inside of Netlify's dashboard, but Netlify supports different environment variables depending on if you're in a production branch or a preview environment. You don't want your previews connecting to your production database, so this is how some of this stuff gets set. And I had to use some bash scripts in order to pull this magic off inside of GitHub Actions. npm install build, pretty self-explanatory. We're building stuff here. Clean deploy directory. I host my sites in S3. I host the applications in S3. I'm reaching into S3. I'm clearing out the old artifacts. I'm going to copy the new artifacts and push them into S3. And then I'm going to invalidate my cache. This is the CDN. I don't do the same thing that Netlify does where I push the artifacts out into the CDN. I instead just clear it out. So the first person that tries to access it might see a little bit of performance hit, but it's going to populate after that, and everyone else should see it nice and quickly. This is the GitHub action workflow for the backend. We're going to spend less time here because a lot of it's more of the same. But again, on my triggers, I'm only monitoring code that is inside of my backend folder, so I'm not redeploying the entire front end whenever I make changes here. Next up, I want to highlight this step here. This is a step template that is provided by AWS to install the AWS SAM CLI inside of my build container. I highlight this because you can customize the containers and install your own tooling inside of those containers if you absolutely need to. So you get full flexibility with this kind of approach of what you're doing. And then finally, this last step, build and deploy. This uses make to call a bunch of shell scripts that are going to transform the configurations and then use AWS SAM deploy, I think is the command, in order to push things out. But I also wanted to call out here, this is running a set of bash scripts. This is running inside of my backend/stack directory, so I can set the working directory. I can set custom environment variables in order to get very granular with how I want to actually execute these scripts behind the scenes. So again, just leaning into the theme of full flexibility here. And then finally, here is my SAM template. This is that text file that defines all of my AWS resources that I need. First thing I want to call out here is it's parameterized, and this is how I can pass in the branch name for the specific environment and then ship the resources and name them appropriately. As shown down here, this is the definition for my S3 bucket, which holds all the sites here. On line 101 of this sample, you can actually see that I'm concatenating Guardian Forge / whatever the environment name is /site. So I can go into my AWS account and look at the individual buckets inside of there and identify which files are in which environment and get a little more into the actual files if I need to debug things. And then just showing that we can have more than just S3 buckets here. This is a get users function. This is one of my Lambda functions that's run whenever somebody uses a website. And for a dramatic effect, this is the entire file. So you can see there's a lot of stuff that I'm able to do with this single file. I don't think SAM supports breaking this up. It didn't when I started creating this. I'm not sure if it does now. But the real question behind my talk is, why the hell would any of you want to do this when you can just merge code and Netlify will ship it for you? And I have a couple answers to that question. The first one is, the more skills you have, the more opportunities you have. Everyone has told everyone is spreading this message that AI is going to come and take all of our jobs for us. And I hope there are a lot of you that don't actually believe that, because I don't believe it. But that doesn't mean the executives at your companies don't believe that. So they're laying people off left and right just to try and make that cost savings, right? And if you're in part of a layoff wave of 10,000 people, you are now competing with 9,999 other people to get a job just so you can put food on the table. You might be more attractive if you're able to do this plus React versus somebody who's just really skilled in React, because you can provide more value to companies. The next step is you have more services you can use. Netlify doesn't have a queuing service. It doesn't have a built-in database like I showed you that I was able to pull off just using AWS. And this is my favorite one, which is fundamental knowledge. Part of my job for Clerk is I go online on Twitter and I find people who are having issues using the service and I try and help them. You know, hey, let's jam. Let's figure out how we can build something for your solution together, right? And for some reason, there are people that have made it their life's mission to try and convince the world that you don't need to use a third-party authentication service. Build your own auth. And to them I say, yes, build your own auth, because you should know how to build your own auth. You should know how to build your own backend CI pipelines. You should know how to fiddle with servers and figure out how to do all this stuff, because only once you have the experience of doing this stuff will you actually be able to make an educated decision whether or not any of this is worth it for you, right? Like, this is some crazy monstrosity that I put together, mainly because I was trying to learn this stuff. But I use Vercel for most of my stuff these days because they make it easy. But at the very least, what I can do now that I know it is I can appreciate what Vercel and Netlify do for me, and then I don't have to worry about it. And I fully respect anyone here who does not want to take this on and just use the available tooling. But let's say you're on the other side of that coin and you're like me and this stuff really gets you fired up, right? So I got some tips to get you started. The first one is start small and grow. Don't do something like what I did unless you want to, then by all means do it. But you can create something very simple like a GitHub Actions that uses the Netlify CLI to deploy the site for you, right? Instead of relying on Netlify to come into GitHub and grab your code and pull it to them, use the CLI in a bash script to push it to them instead. You'll get the same effect, mostly, and you'll learn something along the way. Next up, you should know your ecosystem. I work a lot in the JavaScript. One second, I need to take a drink of water here. I work a lot in JavaScript and TypeScript these days with the work that I do, but as I mentioned, Guardian Forge's backend is built with Go. Before that, I actually did a lot of work in the .NET ecosystem. That was my bread and butter. That was my bread and butter for a long time. All of those ecosystems build things in different ways, ship things in different ways. So the more knowledge you have in your particular flavor of language or framework that you're using, the easier you're going to be able to build and debug these types of pipelines. Next up, learn how to automate. A lot of things in my workflows were all bash scripts that were cobbled together to create some desired outcome, right? So whether it's bash, PowerShell, or whatever kind of shell you want to learn, learning how to automate stuff with shell scripts makes this whole process work a whole lot better. Gives you a lot of flexibility. If at first you don't succeed, audience participation. Moms and dads told us we fall off a bike, try again. Building DevOps pipelines take this concept a little bit farther, okay? If you're gonna get started in this, you're not gonna build something and get it right the first time or the second time or the 100th time. And that's kind of just the way that it goes. You're gonna build something and just kind of trial and error your way through it. Last year when I gave this talk, I built the demo that actually supports branch-based deployments. And it took me a couple of hours to like fiddle through it and get it all working the way that it was supposed to, so it was in a nice, repeatable way. That's just kind of the nature of the beast. But once it actually works, I mean, it's like your mind's blown, you feel great. It's such a fulfilling feeling. The last step that I have for you is there is no one right way to do a lot of this stuff. If you get excited about this and you go out and you buy the DevOps literature books, right, you will find out that they say there are 8 distinct phases that you should follow in order to implement DevOps in your environment. And those really should be considered kind of like guidelines or best practices. I've worked at several companies where I've been relatively in charge or involved in these types of pipelines, and not a single one of them ever followed all of the 8 phases to the T the way that they were supposed to. So what I like to tell people is as long as you can build and ship your code, get it from works on my machine to works on everybody's machine, do it quickly, do it securely, efficiently, ideally test it. I don't know. Tests are good. As long as you can get it from point A to point B and do it in a repeatable way, it's a good thing. And finally, I work in developer marketing. And developer marketers love their logos, so I have a bunch of logos on the screen for you, okay? I don't expect you to know what all those are, but there is a QR code there you can scan that will link you to a page on my website that has a bunch of resources that can help you get going with this process, whether it's guides and tutorials that I have created over the years to links to a lot of these services here, and then some. There's also a recording for the whole talk, which contains the actual live demo portion of this. And then once this talk gets fully published and I have the video copy, I'll link that there as well. By the way, if anyone has any resources that they think others would benefit from, please DM me. And that goes for anybody out there watching live. If you want to get in touch with me, DM me. And let's nerd out about this stuff. Thank you for joining my talk. My name is Brian Morrison. 47 seconds to spare. Whew, we did it. All right, any questions, we'll take it out in the hallway track. Or again, DM me online. That's my contact info.